My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 116. In this lecture, we will try to understand hypergeometric distribution. The hypergeometric distribution is a discrete distribution. First, we will try to understand relation between binomial distribution and hypergeometric distribution. Binomial distribution is applicable when selecting from finite population with the replacement. Otherwise, I will write this is applicable when is selecting from finite. What is your population size? Your population must be finite population, and other characteristic is with replacement. With replacement means you can apply binomial distribution if you select from finite population with replacement or from an infinite population. There is another case. Instead of finite, I can say an infinite population. Infinite population without replacement. These are the two occasions without replacement, in these two occasions you can apply binomial distribution. There is our interested topic. Today's topic is hypergeometric distribution. Whenever the concept of without replacement comes, then we have to think of using hypergeometric distribution. The hypergeometric distribution is applicable when selecting from, otherwise I will write, when selecting from finite population, finite population without replacement. This point is very, very important. Without replacement. Yes, when can I apply? Hypergeometric distribution means hypergeometric distribution is applicable when selecting from finite population without replacement. This property is very important. When the item is chosen from the population, it cannot be chosen again. That's what without replacement says, isn't it? You have to think of using hypergeometric distribution whenever the concept of without replacement comes. Use the hypergeometric distribution for samples that are drawn from relatively small populations without replacements. Again, I am repeating. It must be relatively small populations without replacement. I already discussed without replacement. Otherwise, let me repeat. Use the hypergeometric distribution for samples that are drawn from relatively small populations without replacement. The hypergeometric distribution is used in Fisher's test. This is one of the important statistical tests to test the difference between two proportions. We will try to make use this particular test in our future classes. The properties of hypergeometric distribution are: if sampling without replacement from a finite population, then we have to go for hypergeometric distribution. I am repeating the same point again and again, as it is very important in solving many real-time applications. The number of objects in the population is denoted by capital N. Each trial has exactly two possible outcomes, such as success and failure, which is similar to binomial distribution. Even in the case of binomial distribution, we were saying that there are only two possible outcomes, success and failure. Trials are not independent. This is one different property when compared to binomial distribution. In the binomial distribution, since we are going with the replacement, the trials are independent. Here we are going without replacement, so the trials are not independent, means trials are dependent. Here x is the number of, I can say like this. Therefore, in order to understand hypergeometric distribution, you should be very familiar with the binomial distribution. The probability P is not fixed every time. You will get different answers for the P. In the case of hypergeometric distribution, x is the number of successes in the n trials. The binomial is acceptable approximation if capital N by 10 is greater than small n, otherwise not. What is my capital N here? My capital N is population size, whereas my small n is sample size. The probability mass function are used to describe discrete probability distribution, while probability density functions are used to describe continuous probability distributions. As hypergeometric distribution is discrete distribution, the PMF, the probability mass function, is P of x equal to ACX into n minus a c n minus x by NCN. Here you must understand parameters. What is my capital N? Population size. Small n, sample size. Capital A is the number of successes. Small number of successes in population. Small x is number of successes in sample. You must understand here two types of successes are there. A is the number of successes in population. X is the number of successes in sample. Mean value of your hypergeometric distribution is A into capital A into small n by capital N. Variance is sigma square equal to A into capital A into n minus capital A into small n into capital N minus n. This is anyway simple formula, anybody can understand. Here just to go through this point again, what it says? It says the binomial distribution is acceptable approximation if capital N by 10 is greater than small n. What is my capital N? Capital N is population size, small n is sample size. I can say like this. In fact, the binomial distribution is very good approximation of the hypergeometric distribution as long as you are simply 5% or less than of the population. Just anyway, this is one important point. Even if you are not able to follow this point, I will discuss some numerical problems in future classes. There you can understand. Time being, just understand these points are very important. Which point, when applicability, you must understand applicability of binomial distribution and Poisson distribution. Don't forget, try to understand this point. When can I apply binomial distribution? I can apply binomial distribution in the case finite population with replacement and infinite population without replacement, whereas application of hypergeometric distribution is finite population without replacement. Just go through these properties so that again and again, let me say same point, the hypergeometric distribution is applicable when selecting from a finite population without replacement. Finite population without replacement, as it is very important. I am repeating many times, this is applicable when finite population without replacement. Just I discussed what is probability mass function in the case, as it is discrete distribution, we are saying probability mass function. If it is continuous distribution, we used to say probability density function. Just go through this lecture, just understand the difference between binomial distribution and hypergeometric distribution, so that I will discuss few simple problems with the help of Python programming language in my next lecture, that is lecture number 117. Thank you very much.